Good morning, everybody. My name is Dave, and we're going to do a little workshop here on PowerShell using in offensive operations in 2023. So I'll give you a brief history of who I am. So my name, again, is Dave Story. If you're still using Twitter, you can find me at C1Dave. I wouldn't bother, there's not a whole heck of a lot there worth following for. My job title is Adversarial Collaboration Engineer, and I work at a company named Lares. We do security testing for organizations. We have an AppSec practice, we have a NetPen practice, advisory services, etc. I work in the adversarial collaboration unit, which means that we do what most people would call purple teaming or purple team tests. So we help organizations harden their infrastructure against red team tradecraft. I started off my career as a sysadmin, and part of my roles as a sysadmin was I was responsible for defensive security, so my job was to make sure that the network was safe from threats. I then transitioned into what we would call offensive security, so I do security testing, and I did that because I wanted to better learn how to defend networks against adversarial tradecraft. And I then moved into a red team operator position and later a red team operator position on an internal team right before joining Lares. So I enjoy making and repurposing offensive security tooling, which is kind of what we're here to discuss today. And aside from computers, I spend time with my family. I cook, I like to play drums or pretend I play drums and listen to angry music. So today's workshop, let's kind of level set on what we're here to discuss. So what I want to do is intend to highlight how PowerShell can still be used in offensive operations, and we'll kind of dive into definitions of what I mean by all of this in a few slides here. So what we're going to do is we're going to start with basics, and we're going to kind of work our way up to what we would call a pseudo tool, right? So again, my background is largely in offensive security, so I worked as a red team operator. We'll define those in a minute here for those of you who may not be in the know. And so for each of the offensive capabilities we demonstrate, because we do purple team things, we're going to put a purple team spin on it. We want to show how it might have been detected by an organization, right? So I want to stress that this workshop is not going to help you build a super elite tool that is going to bypass antivirus and EDR. That's not the point of it here. The point is to provide the building blocks as to what we would do and what we still do to this day in operations and in offensive testing to action the objectives, which means is to succeed in our objective. So one quote that was told to me when I was in a course that I have really stuck with me is that publicly available research generally only goes an inch deep in a deep pool, right? And what that means is that there's a lot of stuff out there available on the internet that if you repurpose it and you really understand the technology that's happening underneath all of it, you can really repurpose it to suit your goals and evade detection, right? So we're going to operate today under the mantra of work smarter, not harder. So if a tool exists, let's look to repurpose it for our purposes and rather than rebuild a new tool. So PowerShell in 2023, I know, right? We thought that the PowerShell problem was dead. So despite what many people are going to tell you, PowerShell is still alive and well and being used by adversaries today. And so don't believe what you hear. The rumors of PowerShell being a dead thing for us in the offensive security is far from true. So it is still widely used by threat actors in network intrusions. We'll dive a little deeper into that in a few minutes. So Conti is a well-known ransomware gang, and their playbook, they hand it to their operators. This is what you do in a network intrusion. Was leaked and translated to English in 2021. So there are multiple references to the tools that are leveraged as part of their what we would call a kill chain, right? So when they get into the network and they navigate through the network, and we would call this a kill chain, right? So we see references to sharefunder.ps1, invoke Kerberos.ps1, invoke smbautobrute.ps1, CVE 2021-34527.ps1, which we know as Print Nightmare, and then they also look to disable Microsoft Defender real-time monitoring. So these are the definitions according to me as far as the offensive security stuff is concerned. So first we have penetration testing, and penetration testing is really meant to identify as many technical vulnerabilities as possible within a network. Okay, so the idea is that you may have to contend with EDR, AV, and antivirus, which is a typo, and other technical controls. You may have to contend with that. What you are not going to have to contend with, generally speaking, in a penetration test is threat hunters and people looking to evict you from your network. You are there, it's typically known that you are there, and you are conducting a test to try to find as many vulnerabilities as possible within the network within the time frame that you are given, okay? So an objective for a penetration test is going to perhaps be gain global admin rights in the company's Azure tenant, okay? It is not a clandestine test. People are aware that you're doing the testing. They may reach out to you to say, hey, we saw this, was this you? But they're not gonna try to kick you out of the network, okay? So that's what we would call a penetration test. A red team test is an objectives-based assessment designed to test an organization's resilience to a motivated threat actor. And what I mean by that is, generally speaking, pen tests are, let's try to get the highest level of access we can within the network or within the objective. With a red team, that may not be the case. They may say that our crown jewels are this proprietary web application that we have. We want you to try to get access to the source code and exfiltrate it without detection. Okay, that's what a sample red team would be. So red team operations have to contend with all of the technical stuff that we had discussed before, the AV, EDR, which stands for Endpoint Detection and Response, and they may deal with anti-spam, any of the technical controls that a pen test would have to deal with, but you are now also contending with the human element of things, which is the people that are paid to try to make sure that you don't do what you are setting out to do. We would generally call these people blue teams. They could be called SOC analysts. And the blue team is generally comprised of people with a number of different titles, threat hunters, incident response, CSOC or SOC analysts. So we have to contend with that as well. They're going to try to see what you're doing and make sure you do not action your objective. These tests are typically carried out in an ideal world in a clandestine manner, which means that the SOC is not aware of the test prior to you starting it, and so that you kind of get your real element of surprise. And so, again, an example objective of a red team operation would be to potentially exfiltrate source code of a company's proprietary web application that they want out there, okay? It could be any number of things. Anything that keeps the security staff up at night is, likely to be a good objective. It could be stealing data, it could be accessing PII, whatever you have it, okay? Anybody have any questions on that stuff before we push forward? All right. So let's go into my red team philosophy, okay? This will all make sense as we go forward, but I want to make sure that we level set and make sure that everybody is on common ground as far as the definitions are concerned. So most of this context is going to revolve around red team operations. That is, we are trying to do things in a clandestine manner without detection from a SOC, okay? So pen testing tradecraft is different from red team tradecraft. And so this is the stuff that you would use on red teams. And we also want to highlight how a blue team could potentially detect what it is that we're doing, okay? So nothing, every action potentially has a risk when you're on a red team operation. You might do something that might trigger an alert. And so that's what we want to highlight. So we're going to work towards building some detections on some of the stuff that we're discussing today. So an important element of a red team operation is you need to understand what it is your tools are doing under the hood. Whether or not you believe it, the red team is really an extension of the blue team. It is the red team's job to help highlight what it is that they've done and tell the blue team how they may have detected that. And then, we help build detections around that, right? So it's important for the red team operator to really understand what's going on when they're executing tools, okay? Your tools absolutely will get burned. Make no mistake about it. If you work in a red team operation, someone's going to upload your stuff to VirusTotal. Someone's going to upload, they will publish it. It's going to happen. It's an inevitability. Prepare for it. Just be aware that that will happen. No matter how hard you may try to prevent it from happening, it absolutely will happen. That's part of the game, okay? That is the risk that we take with, doing these types of operations. So with that said, we want to build small, purpose-built tools that accomplish one thing, or generally one or two things, okay? So if a piece of your kit gets burned, they only know about one small aspect of what it is that you were trying to do. And the last piece is really more of my thought process, but be humble, okay? Red teams, we love to win. We love getting DA, we love accomplishing objectives. Everybody likes to win, okay? But the reality is that we are all on the same team together, so be humble when you're talking with people who work in a SOC role. Okay, nobody likes to be, that guy who said, I pwned you, right? You're gonna just create an adversarial relationship with the SOC, and really what you're supposed to do is be able to work with one another, and if you are adversarial with your counterparts in the blue team, you are then kind of creating an adversarial relationship, and it's counterproductive towards getting things done, okay? So the blue team philosophy. PowerShell logging is your friend. We've been saying it for years. we love PowerShell logging as far as the blue team is concerned, and we'll highlight some of what it's capable of detecting when we dig a little deeper in. So learn to read PowerShell code. It's really easy. It's quite, if you're working a SOC position, it's quite easy to understand what's going on. That's one of the benefits of PowerShell. It's very easy to read language. And when you're reading stuff like that, you may be able to determine what it is that your threat actor is doing. If you're seeing LDAP queries and they're looking for machines named Git, or code repo or stuff like that, you might be under the, you might be able to tell, hey, that person's trying to access our code base, and monitor the code base more closely, right? So we always preach to hunt tradecraft and not tools wherever it's possible. If you guys remember the Conti playbook, we had invoke Kerberos.ps1. Well, what that's going to do is do a Kerberos attack, and it requests tickets. This detection, is better served on the domain controller side, so you would be monitoring for the request of these tickets and not necessarily strings contained within that PS1 file, okay? So when it's possible, let's try to hunt on tradecraft as opposed to specific tools. Tools can always be modified. We can change hashes, we can change strings. Look to the best possible detection metric, which is typically hunting what the objective is of using that tool as opposed to the tool itself. And so baseline your environment is crucial for tuning these alerts. This is kind of the piece that nobody really wants to hear, but is the sad truth. Any EDR vendor will say, yeah, it's like turnkey, just turn it on and it'll be ready to go. The reality is that you need to tune alerts to the environment that you are monitoring, okay? Some sysadmins do crazy weird stuff that looks like adversarial tradecraft. It is legitimate, okay? And we'll jump into this in a bit. Like, we've seen just wild things. People telling me that they've seen processes spawn in the most bizarre things, because oftentimes people are just trying to do something that works to accomplish their daily roles, and sometimes that looks like something an attacker would do. I was talking with a friend of mine yesterday. I said, hey, I've been playing around with Microsoft ATP. It does some really weird stuff, and we'll actually jump into it a little bit in here. And he's like, yeah, it essentially looks like a rat or remote access Trojan. It does very bizarre things, but if you know that your tooling is doing that, then you can tune your alerts effectively to try to figure out what it is that you want to exempt from alerting logic. So the last piece I'd like to say is, don't let perfect be the enemy of good. Sometimes the red team say, well, that's a fragile detection. I could bypass that. That's cool. It doesn't mean you shouldn't do it. If we could lockpick your front door if somebody knows what they're doing as far as lockpicking is concerned. That doesn't mean that you don't lock your door at night, right? You need to try to make sure that you are covering off as much as you possibly can to reduce as much attack surface as you possibly can. So let's go through a really brief history of offensive security tooling. So, dates according to Dave, I will sit as the. It's kind of hard to tell when it was that PowerShell really started gaining momentum as far as offensive tooling is concerned. It's around 2012, 2011-ish. And it becomes the king really, really fast. PowerShell is incredibly powerful. It lets you interact with all elements of the Windows operating system, lets you do remote interactions. It's super powerful, and the offensive security community recognizes this. They start building tooling for it. 2015, Microsoft releases PowerShell 5, which allows us to now see what is going on within a PowerShell script and log that with Microsoft script block logging. And there's a few different ways that you can log PowerShell, but we'll focus on script block logging for this particular discussion. They also introduce this technology that's called the anti-malware scan interface, and what its intended purpose is at runtime, when a script executes, whether it be VBS, PowerShell, blah, 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 the AMC interface inspects it to see, is this doing something bad that I should be preventing, right? And so the combination of the script block logging and AMC has, the red team tradecraft basically shoving PowerShell to the side, and really adopting C#, which has very similar syntax as far as PowerShell is concerned. So they basically just say, we're done with it, move on to the next. And so offensive security starts to code a lot of their tools in C# to circumvent AMC inspection. So let's fast forward to today. Well, guess what? C# now is subject to AMC inspection too. Many teams have moved to developing tooling in unmanaged code languages like C, C++, Rust, Golang, etc. Each of these languages has drawbacks. I should state that every language has its drawbacks, okay? So it's important to understand the pros and cons of each. So C++ requires, the appropriate runtimes to be installed on the target machine, which is typically not an issue, but it's worth noting. It can be difficult to code in if you're not used to coding in unmanaged memory languages. C has a very steep learning curve. I mean, C is notorious for being difficult to code in if you've not worked with it heavily before. And it's very easy to make mistakes, and in my experience, the C compiler is all too ready to let you make those mistakes. It won't complain, it'll just say, yep, you do you. Rust produces large binaries. It's relatively new, not super well understood by many threat actors. Golang is the same. Golang just generates absolutely massive binaries. Do you have a question? Oh, sorry. No problem. All right. So the PowerShell of yesteryear. So it's important to note that even though PowerShell is used a lot in adversarial tradecraft these days, the tradecraft has changed a little bit. Okay, so the PowerShell gained massive popularity in its heyday because its ability to operate fileless malware, which is you could issue a request to a remote resource, load that code into memory, and execute it without ever putting a file on disk. So this tradecraft often leveraged what we would call a download cradle to load a remote PowerShell file into memory and then execute. So this is kind of what it looks like. So we're saying invoke the execution, we're creating a web client, we're downloading a string into memory. Bob's your uncle, right? Another common tactic was to invoke a PowerShell.exe and then have this long line of strings here, right? So not, non-I, W hidden, exec bypass, etc. So tac not means no profile. Tac non-I is short for non-interactive. TAC W hidden means don't pop up a screen. And exec bypass is the execution policy bypass. And then the TAC ENC stands for encoded, so base 64 encoded. If you're monitoring for command line activity, this sticks out like an absolute sore thumb, right? So blue team really learned to look and hunt for these two items like this. So this is not what we would see very commonly these days, but it's worth noting where we came from in order to see where we're going. So nobody uses PowerShell anymore. I mean, respectfully disagree. We have multiple references of experts warning of PowerShell backdoor disguising as window updates. This is October of last year, so like that's, what, 3 months ago? Threat actor APT 35, Iranian threat actor observed using PowerShell modules in unmanaged PowerShell, allowing command and script execution. So despite what you may hear, especially if you roam around in offensive security circles, PowerShell is absolutely still used in offensive security operations these days. So why do we like PowerShell? Well, it's ubiquitous. I mean, it's basically installed in any modern operating system. If memory serves, it was released as part of, or at least supported as far back as Windows XP Service Pack 2. It's accessible. Even environments with tight application whitelisting, PowerShell scripts are frequently allowed to run. So that's a nice thing. If you're operating in a very mature environment or an environment that has application whitelisting, which prevents you from executing unsigned code or untrusted code, PowerShell may be where you need to be. It's used often legitimately. Oftentimes, businesses will use PowerShell for any number of things within an organization. It could be to map shared drives. It could be to collect telemetry from your machine for EDR, any number of things. PowerShell is used legitimately, and so it's nice for us to be able to try to blend in with legitimate usage of PowerShell. It's flexible. Its inherent use of the .NET framework and its capability to interact with Windows 32 APIs allows for a really wide variety of uses. And it's easy to test whether or not it's going to work against defensive products. Again, AMC is something that ships with many antiviruses these days, so it's something that we can test and see, is the code going to trigger AMC, yes or no? So all this building up of PowerShell requires a bit of a disclaimer. So to be clear, PowerShell is not a silver bullet, okay? I want to make that very clear. Like I said, there's lots of pros and cons to any different tooling that you could use. It would not be my first choice if I was going to operate in a very mature environment or an environment that I thought was going to be very mature. So the logging gives excellent insight into what your script has done and what you are trying to accomplish. So this may be something that is used for alerting. It may also be something that if you were caught doing something else, they'd say, oh, let's pull the script log logs, or let's pull logs for that endpoint or whatever. And it could be used as a forensic artifact to try and figure out what it is that you've done or what you're hoping to do, okay? .NET assemblies can be trivially reversed with tools like DNSpy. I think ILSpy is the new hotness in that respect. You can correct me. And then using PowerPick or PowerShell without exe can be very loud due to the fact that it's going to load DLLs associated with PowerShell into processes that may not have those DLLs natively loaded into it. This is associated with the common language runtime, clr.dll. So, all red team tradecraft brings risks. It's up to you to understand your environment and act accordingly. Decide what will be best for you as far as acting prudently, right? And so the underlying message with today's workshop is that in many cases, not all cases, in lots of cases, PowerShell can still be used effectively within offensive security tooling. So let's go through a little bit of a few basics here. So PowerShell commands are known as commandlets. That's how that's pronounced, commandlets. And these are instances of .NET classes. They are not their own executables, right? They are executed within the PowerShell process. These commandlets typically use a very standardized nomenclature as far as naming is concerned, and it's typically noun. What is it? Yeah, verb noun. Thank you. Verb noun, right? So we have a whole list of verbs here: get, set, add, new, find, invoke. We're not going to go through all of them, but just know that if you have a PowerShell commandlet that is like get so-and-so, there's probably a set so-and-so. There may also, it works vice versa. So these are the common, these are perhaps the most common of the verbs associated with it. If you wanted to see a full listing, I would recommend, looking up the PowerShell documentation offline. So we can string commands together really easily with PowerShell with just a semicolon at the end. So what we're saying is if we want to do a big one-liner, we could just do a command, semicolon, and then another command. So in this case, we're saying E equals get process, and then E.count, and we see that on the machine that I ran this on, there were 159 processes running. So get process is just a commandlet to show all of your running processes, and then so we assign it to the variable E. E.count will show us how many of those there are, and we see 159. And we see that PowerShell is extremely forgiving for doing all manner of weird, wacky things. Okay, so E equals and then like 15 spaces, get process, and then we capitalize count. PowerShell is very forgiving with spacing as far as capitalization is concerned. So it lends itself well to obfuscation. If any of you guys have ever looked at Empire or any other malicious PowerShell, you'll see that there's lots of capitalization, lower capitalization, stuff like that. That's what's happening there. They're taking advantage of the fact that it's very forgiving as far as capitalization stuff is concerned, and spacing. Aliasing. So this is a fun little PowerShell thing. So like many things in Windows, PowerShell gives you like 5 different ways to accomplish the same objective. For instance, so if we wanted to print all of the files within a directory, we could use GCI, which is just short for get child item. We could use dir, we could use ls. So we have 4 different commands that essentially do the same thing. And the reason for that is because they are all aliases of get child item, which means if you type GCI, PowerShell knows under the hood to invoke the get child item command. So again, aliasing, the ability to assign an alias to things, is something that allows us to do some sort of obfuscation, right? So import module has an alias of IMPO. All of those PowerShell one-liner before where you saw non-I. Non-I is literally just short for non-interactive. Each one of these can be extended. PowerShell is very good about giving you abilities to kind of compress some of these items or some of the commands, okay? So it's important to note that there is the flexibility there, and so sometimes you'll see me type things, and I try to do things as verbosely as possible in this, just to give you guys all a overview of how it's, what's actually happening. But just be aware that aliasing is a thing. We love it. If you're a Linux person and you've typed ls in a cmd.exe thing, your problem is solved in PowerShell. Use ls. I do it all the time. It's great. All right. The $_ variable. This is like a weird PowerShell-ism that I don't know of it exists in any other language, but it's worth talking about. So the $_ variable in PowerShell is a bit unique, and it's actually an alias for the $PS item commandlet. So the $_ variable is typically seen when you're doing like a looping operation, and what we are saying is perform this action for the current item in the loop. Okay. So if we did get process for each $_ dot process name, we would see a listing of just the process names. And let's see if we can. I'm going to roll the dice here. Uh-oh. Already done it. Okay, we're going to call an audible and not actually do that. Oh, maybe we are. No, not. All right. So if you wanted to follow along, you could type get process, put the pipe mark for each squiggly brackets or braces, depending on what camp you reside in, $_ dot process name. And what that's going to do is do a get process and list the property for the process name for each one of the processes that's running. So let's put it all together and make a useless little one-liner, okay? So let's set an alias called getProc and to get process. Then we're going to invoke the alias, and then for each of them, we're going to do the $_ process name. So what we're going to do is set an alias, and this is a silly one. It really accomplishes nothing of function, but it's just an outline as to what you guys can do. If you're following along and you wouldn't happen to have an Active Directory machine, this is just something simple, right? So that's what we're doing here is the set alias, get proc, so our new alias will be named get proc. It's aliasing to get process. We call it, we say for each process name, okay? All right, that's enough boring stuff. Let's get to the more fun stuff, shall we say. So, exercise number 1, and if you are all working on a Windows machine, you can probably follow along with a good chunk of these if you were so inclined. I'm not sure if we'll provide the slides after the fact, but if you wanted to on your own time, then let me know. Hit me up on C1 Dave if they don't distribute it on Twitter, and we'll make sure that you get them. So exercise 1, this is actually, remember the previously mentioned Conti playbook? This is the first part of the Conti playbook. And so when they land on a machine, this is what they're telling their operators to do. Do shell whoami, shell whoami / groups, shell nl test, DC list. We won't go through all of them, but you get the idea, right? This is what they're telling each one of them to do. So one thing I will tell you all is that they're using a tool called Cobalt Strike, which is a backdoor. The shell command that prefaces most of the other commands is basically telling Cobalt Strike to do cmd/c and then this command, okay? So if you see shell, just remove it from your brain. These are basically Windows executables, okay? So in some mature environments, just doing this alone is going to get you hosed, okay? It'll get you evicted from a network because this is very suspicious behavior of you doing obvious recon. This is especially true if people are monitoring for this within a relatively short period of time, right? So if you say, if 3 of these are executed within a 5-minute time period, send an alert to an analyst to investigate, right? So right out of the gate, this stuff might get you kicked out of a network if you're doing a red team operation, right? So let's look. So whoami is a command line utility. It's actually whoami.exe. And unless you've done something to change where Windows has been installed, it's going to be installed in C Windows System 32. So when whoami is entered into a command prompt, what's happening is cmd.exe is spawning the whoami.exe process and then returning the result to the screen for you. Okay, so we see here in this little screenshot, cmd.exe is the parent of whoami.exe, and so parent-child relationships is important in detection engineering. In this case, we see that cmd.exe spawns whoami.exe, and when you are hunting on things like whoami.exe, it's very easy to hunt, hey, is whoami.exe been spawned, right? The same is true for most of these commands. So net is really good, so cmd will spawn net, and I believe spawns net1 after that .exe, which is bizarre. So most of these we can just hunt based on if that process is spawned. That would be funny, right? So if we wanted to do whoami, but didn't want to do whoami, here's how we might do it in PowerShell. So we offers a few different ways of doing it. We can use the environment variable, which is just username. So just type $env and then :username, and that's going to respond with Michael Scott in this case. If we wanted to replicate the whoami output, which means we wanted the domain prefacing the username, we could do that by using the namespace system security principal and then the Windows identity class of it, and we get this nice long one-liner, but it gives us the exact same information before. So what's happening here is that PowerShell is doing this within PowerShell. There is no additional spawning of another process, which makes it a little bit harder to hunt for, okay? So, same but different, a popular saying in Thailand. Probably cause to look for an alert, okay? So anytime anybody's querying domain admins and enterprise admins, those are 2 very suspicious queries. I would say we could probably look through the PowerShell content and create an alert based on that alone. In fact, I believe Microsoft ATP will do that. We'll say, hey, this is a suspicious ATP, and raise an alert for somebody to investigate. The second thing that is kind of weird is like env username is probably something that not many people in your organization actually do. There may be a script that uses it. Again, all of this is subject to change. Different environments are crazy. We've seen some pretty wild things as far as people just solving problems that was legitimate. So env username maybe is something that's weird in your organization as well. Might be something that might be a sign that somebody's in your network you don't want to be, and then you flag for an alert. So it may also be prudent to set times on these processes, right? So like if 4 of those commands happen within 30 minutes, trigger an alert, somebody's got to investigate, right? So that's how we might look to investigate that. This is Splunk. If you guys are unfamiliar with what Splunk is, it's what's called a SIEM, Security Information and Events Management. Thanks for nothing, Lee. Security events, and so what you do in a SIEM is you forward all of your logs, or as many relevant logs as you possibly can, into your SIEM, and you can analyze those, right? So Splunk is a very popular one. There is a free trial, so if any of you guys wanted to try and play around with some Splunk, you can do that. You can request a free trial in order to play with it. So this is in Splunk, and so what I'm doing is I'm forwarding all my PowerShell logs into Splunk, and then I can create queries, a nice monster query to look for all the bizarre things that may or may not be happening. You guys will notice the regex with the stars and the backslashes. If you want to get in detection engineering, I mean, I'll tell you all right now, if you work in information security, you're probably going to have to get good with regexes. Don't avoid it, just embrace it. So anyways, this is what's going on here. If you see the stars and the backslashes, that's regex food. Questions, comments, concerns so far?
I guess kind of going back a little bit, so the content gave a lot of these away. Is there anywhere where, since especially as PowerShell's log a lot of time, is there anywhere where other threat actors have like their TTPs or PowerShell commands that they've run like kind of available online?
Sure, yeah, that's a great question. So the question for those of you who may not have been able to hear is if there are collections of TTPs that other threat actors have run. I'm not sure if any of you are familiar with MITRE. MITRE has what we call the attack framework, and so it's a listing of TTPs. And MITRE maintains groups of so like threat groups, all their TTPs associated with it. So if you went to, and you know what, if you've got questions, I'll write it down for you at the end. So attack.mitre.org, if I'm not mistaken, and if you search for groups, it will list you a whole bunch of groups, you know, everything from APT29, Lazarus group, any group that there's publicly threat intelligence on, it will list all of their TTPs there, some of which are a little older, you know, like a Cobalt group hasn't been active for a little while. APT29 was associated with a DNC breach in 2016, if I remember. So that's a great question, absolutely. The MITRE attack framework keeps listings of groups and their known TTPs.
Thank you.
All right. So now that we've gone through that exercise, how do we know what commandlets can do? Well, first off, you can do Google if you wanted to, but PowerShell commandlets offer you a lot of flexibility and power if you know how to leverage them properly. So each commandlet can be piped into what's called a get member commandlet, which will show you the methods and properties for each one of them. Methods are similar to functions. They're typically something that can be done with that data. A property is exactly that, is an attribute that is associated with that you can pull up. So when we were doing process.name, the .name is the property associated with that. So if you wanted to, you could do get process, get member, and you should see a whole bunch of, you should see alias, properties, events, method, note, so on and so forth. So in order to really leverage PowerShell, it's important for us to understand namespaces. And all a namespace is a logical grouping of code in the .NET framework. And so this is kind of a breakdown because I know it can be overwhelming looking at these really long lines and saying, you know, but being able to understand what is what will really help you write your code. So we have 4 different things that are going on here. We have the namespace. So if you guys remember, this was what we had used to produce the who am I stuff from before. So we've got the system security principal, that is the namespace. After that we have class. After that we have the method, which is get the current user, and then we want to see just their name. Okay? So namespace, class, method, property. Typically after the double colon, you're going to get the method, and then there is a dot here you can't see, but there's a dot name. Hopefully this will make a little bit of sense as we keep going. So let's discuss encoding data. Encoding is a technique that's often used by illegitimate and legitimate software engineers and authors of malware. So there are numerous types of encoding. Today what we're going to do is we're going to focus on base64. We use this quite often, is base64. So on the malware side, there's a few inherent benefits to base64 encode. Number one is there's a bit of obfuscation by design. You're just going to look at the string is going to be a whole lot of gobbledygook essentially. If you're creating payloads with shellcode, they're usually smaller than using other formatting. So the one on the left here, the \x00 would be what we call C formatting, and 0x00 would be what we call C# formatting. So base64 encoding and decoding functions are natively supported by lots of modern languages. So it lends itself well to transforming it, and then we can kind of modify it in a different language or invoke it in a different language. So encoding a string, and for anybody who's unfamiliar with a string is basically just like a line of text. Encoding a string in PowerShell is a 2-step process. The first is we need to convert it to a set of bytes. The second is we convert those bytes or the byte array into a string that is base64. So we'll walk through it real quick. sounds worse than it is. If you wanted to follow along, here's the code. So we have a plain text variable that is just PowerShell Workshop. So we're going to assign to the bytes variable system.text.encoding. So this is, remember, our namespace. And so this is a namespace in class. We're going to use the UTF-8, class, and we're going to get bytes as the method, and we're going to convert it to plain text. And then in any time in PowerShell where you just see a variable, like $bytes, what you're doing is just writing it to the screen. You're writing it standard out, okay? So what we do is we do that, and then we would see, what we've done is essentially converted a string to UTF-8 bytes, and so we can confirm that if we wanted to. And so now that we've made a base 64 string, if we wanted to make a base 64 string, we need to add the extra line of code. If we wanted to do a nice big up one-liner, we could do that with this by embedding a function within the other function. So this is like a slightly more streamlined way of doing it. So what we end up with is a base 64 string that looks like what we have above. So this is base 64 encoding for anybody who's not familiar with it. We have the bytes that are converted from base 64. We wanted to convert it back. So we're taking our string, we're saying convert it from a base 64 string, then put it into plain text, and then put the plain text, right? So we have more efficient. So now that we know how to base 64 strings, what else do you think that we could encode? Spoiler alert, it's files. So remember the base 64 string method that we expects it expects an array of bytes. So that what we can do is import a file, convert it to bytes, convert that to to base 64, and then we can work with that. So if we're following along, you guys can create one called C-users public test to create a plain text. What it's going to do is create a text file, and it's going to save it to C-users public test b64. We'll fast forward a little bit because I'm not sure how many people are following along. But detection. So base 64 encoding in itself is probably not a great high fidelity alert as far as something that you want people to action. But what we can do is, remember the one-liner from before where we had the TAC ENC, which stood for base 64 encoding. We could filter on command lines that have exec bypass or TAC ENC, etc. All right, C# interoperability. PowerShell has many benefits. One of its downfalls is it doesn't deal with some of the programming constructs particularly well. So structs is one of those things. So C# provides some additional programming flexibility that we can use. So PowerShell and C# can both leverage the .network, and with some know-how, you can embed C# code into PowerShell and vice versa. You can embed PowerShell code into C#. So as mentioned earlier, many of the more modern tools have been written or ported to C#. That's why this is important. So we're going to use C# tools and embed them into PowerShell. So leveraging that interoperability between the two opens a lot of doors for us in offensive tooling. So let's explore a few scenarios. So this is a very simple C# program. What we're doing is we're importing the systems diagnostic namespace. We're going to create a class called popcalc, and all we're going to do is spawn calc.exe. That's all this does. Very, very simple, right? There are a few little nuances that you should all be aware of. Prior to coding in C# to save yourself a few headaches. So unlike PowerShell, C# is case sensitive. And unlike PowerShell, you need to end every line that is not the opening or closing of a statement with semicolon, okay? Very simple. Was that 8 lines? Easy peasy, right? So let's find some common elements with our PowerShell code. So on the left, we have kind of the original code, and this is the breakdown. So we are importing the namespace of system diagnostics. There is a class within system diagnostics named process. I know that this may be confusing. We'll get through it. And then within that class, there is a method named start, and what that start is going to do is spawn a process, right? So with that knowledge of what is a namespace, class, and method, we can use that to ascertain that if we wanted to do the same thing in PowerShell, it would look like what we have at the bottom line there. So we're going to confirm the code works, and we can use the csc.exe, which is the C# compiler, to compile the code. Just as a quick aside, one thing I should note too is if any of you are into programming, compiled C# anything is what we call an assembly. So whether it be a DLL or an actual executable, it's called an assembly, not to be confused with the assembly programming language, which is confusing. I don't know why they decided to call it. But for today's discussion, anytime I mention assembly, we're talking about C# compiled code. So if we wanted to, we could compile the code with the C Windows Microsoft.NET framework, CSC.exe, and then without specifying a name for the assembly, it's just going to be matching what the name of the source code file is, which in this case is popcalc. So instead of popcalc.cs, it'll be popcalc.exe. So in the same window, what we can do is just hit up and execute our code, and we see that a calculator is spawned. Alternatively, feel free to double click on the exe if you want. So what we want to do then is we can make use of the add type commandlet and embed our C# code into some PowerShell. So what you can do is open up PowerShell ISE and type the following. So what we're doing is exactly that C# code. We're just prefacing it with $code equals at our code. And then when that's done, we're going to do add type, set the language as C#. We're going to set the type definition to our code variable. And does this look familiar? The popcalc in main. So this is our class. And then, oh, you can't see what I'm doing there. So popcalc in this case is our class, and a : main is our method. So it didn't work. The reason it didn't work is because we have generated a code that is not public. All right, so now we're diving into what's called class visibility. And so by default, classes in C# code are listed as private. We need to set them as public. If a class is private, that means that only code within the same class can access it. So what we need to do is make a small modification to our code, and you'll notice that this code is just slightly different than the code before, where it's public class popcalc, and then public static void main. Okay, so we're stating the method and the class as public. And we're going to do the very same thing as before. We're going to compile the code, and we get our calc. So now what we need to do is figure out what's going on under the hood. So this is Procmon. If any of you are unfamiliar with Procmon, that's what this screenshot is, and it's showing the parent-child relationship between each one of the between what's going on here. So we had PowerShell ISE was where we wrote our code. We hit the play button, and it's executed. Let's see. I'm gonna roll the dice here. No, it's not meant to be. All right, I'm gonna stop playing with fire. So PowerShell ISE, and when we hit play, what happens is we invoke the csc.exe executable, and what that is essentially doing is compiling and running the code on the fly. So from a detection perspective, this is kind of funny, right? Because we have PowerShell spawning csc.exe. It's probably a sign that somebody is using C# code within PowerShell. Now, if that's anomalous in your network, then that's something that you may decide to detect on. So under the hood, I mean, this is what we had just discussed. We see that the CSC spawns the process, and then it's compiled, run at runtime. All right, so detection. So what are some items that may be anomalous behavior associated with the add type, or sorry, some of the items that may be anomalous in your network is the association with add type running C# code. So again, ultimately what's anomalous will depend on your network. Do people do these things? I mean, you might have an eager beaver intern that just does this stuff because they figured out that it's a quick way to do their work, and it's not malicious at all. It will really depend on your network, so this is just an example. So we're going to write a Splunk query that's kind of, that's going to hunt for events where PowerShell or PowerShell.ise spawns csc.exe. So our logic is as such. So the event source is going to come from our Windows logs. We're going to look for the event code 4688, which is that a new process has been created. And the new process name is going to be csc.exe. And the parent process is PowerShell or PowerShell ISE. So with that logic, I see that 39 events happened within the last 24 hours, which is way more than I had expected. I only had created a few of these on this VM for this presentation, and so I was like, well, what's going on there? That's not as anomalous as I thought it would be. If we do a little bit more hunting and we look for Windows Defender Advanced Threat, we see that that is the culprit, and it does this by default. So again, this really just re-emphasizes the point that everything in everything in your network is really going to depend on what's normal within your environment. All right, assembly reflection. This is one we like to use a lot. So let's take a look at the assembly class of the system reflection namespace. So I quote, "This class allows us to create an instance of a type contained within that assembly and invoke one of the methods with late binding." I mean, that makes no sense to me. But what I will tell you is that it allows us to execute a compiled assembly code within with this class, okay? So if we look a little bit further down in the assembly class, we see a few items that look interesting to us, which is load and load file. So this is our source right here. So We're going to change up our C# code a little bit and ensure that the public class is in there. So we have our public class popcalc, public static void main. And so what we're going to do is recompile it again. This is just what we had done before. And so we've already got the knowledge on how to do this. We've built up the knowledge on how we're going to embed this assembly in our PowerShell code and invoke it at runtime. So this is the process. We are going to convert popcalc.exe to base64. We're going to insert the base64 popcalc assembly into our PowerShell script and assign it to a variable. We're going to use system convert from base64 string to convert our base64 code into an byte array. We're going to feed that byte array into a load method of a system reflection assembly. Then we're going to invoke the class. Sounds like a lot. It's not. So, one byte at a time. The first step is that we need to base64 our new assembly, which is popcalc, right? So again, we're going to create a variable called assign bytes. We're going to use a system IO file to read all the bytes. And then what we want to do is base64 those bytes. And what we're going to do is output it to a file called cusers popcalc b64.txt, right? So that's the last we're going to do with this base64 encoding in this payload. This code right here that you see is not going to be in the final payload, okay? So if all goes well, we should have a popcalc base64 that's about 10 kilobytes in size or so. So what I was saying is, sorry, excuse me. So we've encoded the base64 code. This is the last that you're going to see of this code. It's not going to be involved in our final payload, right? So all it's done is taken our malicious C# code and created it to base64 text. So now what we need to do is create the payload. So the first step, assign your really large bit of base64 code to a variable. We'll call it b64 in this case. Easy peasy, right? We're taking the code that was written to the popcalc b64 text and assigning it to the base64. So the step 2 is that we're going to convert that code from base64 and assign it to a bytes variable. Then what we're going to do is we're going to take those, we're going to use the system reflection assembly load method and load it into memory. And we put out null because there's like a true that happens after that. We don't care to see that. So out null is basically the same as dev null, redirect to dev null. And then the last step is we're going to invoke the function with the popcalc class and pass 0 arguments. So if all has gone to plan, we get our calc. So what we have done is we've embedded a compiled binary within our PowerShell code and invoked it at runtime. And so we'll see one of the benefits of doing that is the fact that there is no calling of csc.exe when we do it this way. From an offensive perspective, this is advantageous because we try not to spawn processes if we don't need them. And so you'll notice that the procmon output has PowerShell.exe as the parent of calc.exe, but there's no csc.exe, which we had in the previous test case, right? So again, there are a lot of different assemblies that are using C# these days that you could use this with. We love Rivius, we love sharphounds, we love all manner of these code, and if you're relatively new on your InfoSec journey, then these binaries may be something that is come across in future times. But embedding C# binaries in PowerShell code is very powerful if used appropriately. Now, I will say, in its current form, you're not going to be able to use it. You're probably going to need to do a little bit more work to obfuscate the base64 code. That'll be homework. And encryption is something that you may want to look into. You may want to look into Zora encryption, AES, whatever the case may be. But modifying that base64 code by itself would be beneficial as far as getting it under the radar for antivirus is concerned. So let's discuss detection. So using your SIEM of choice, which again is Splunk in my case, we can create alerting logic based on strings within the actual PowerShell script. So is the assembly load for the event code of 4104, which in this case is a script block logging entry. And then we want to find instances of the text system.reflection.assembly anywhere within the script block log text. Again, sounds complicated, it's not. So remember, baselining is everything. Again, this might be something that is used within the organization that you work in. Maybe, again, you have somebody in your IT department that uses this all the time. They might. In many cases, it may not be the case. So baselining is important. This is not silver bullet logic, okay? And so if we run that, then we see that we have our PowerShell code that's listed here, right? So this is the full extent of the code that was run. And this would then potentially trigger an alert for something to look into. Okay? Execution policy. So, the According to Microsoft, I should say, PowerShell execution policy is a safety feature that's intended to control the conditions under which PowerShell loads configuration files and runs scripts. So it is not intended to be a security boundary. It's not intended to prevent malicious code from running in an environment. It's kind of a, oh, did you really mean to run that sort of thing, right? So we can bypass this a number of ways, and I use the term bypass very loosely. So despite what many people believe, again, it is not a security feature. It's meant to be a safety feature. So there are tons of bypasses that exist. There's an article with like 15 of them out there. We'll focus on 2 today. And there are numerous ways to do it. Number one, if you've been following along, and I know that I've been going at a pace that maybe didn't allow you to follow along, but in the event that you were following along and you were running your code out of the PowerShell.ise window, you would have noticed that your code ran and it didn't prompt you saying that it can't run. And the reason for that is because running your code, if you don't save it in PowerShell.exe, bypasses the execution policy requirements. We've got our little HackerMan logo there. So if you wanted to follow along, you could confirm that your execution policy is set as restricted, which is the default in PowerShell, with the get execution policy commandlet. And so if you haven't already done so, your most recent PowerShell script in ISC, so you can save it as popcalc.ps1, and you can try to import it with popcalc.ps1, and we're going to see that you can't because it's restricted. Your execution policy does not allow you to run that code, which it views to be accidental. So remember the PowerShell of yesteryear, PowerShell.exe exec bypass? Well, you know, that's code of yesteryear. Really what I do, at least these days, is you set execution policy scope current user, execution policy unrestricted. If you try to change the execution policy for the entire machine, you're going to get a prompt saying you need admin. We may not always have admin. If we set execution policy for our current user, we do not require admin, and so that is what I typically do to bypass an execution policy. So, a blue team tip: how many times do you legitimately see PowerShell ISC spawning in your environment? Again, it may happen all the time in IT, but you know, is Jane in marketing using PowerShell ISC? Probably not. I mean, maybe she is, maybe she's not. It depends on the environment, right? So it's important, everything in context, and different users will have different, different behaviors. So the last thing that we're going to discuss, I believe, is the detection on this. If we wanted to, we can just hunt for any time in our PowerShell log where we see somebody issuing the set execution policy command. Probably, again, anomalous. You probably don't see that all too often, especially with most users in an environment. They're probably not trying to set their execution policy. So this would be a hunt to basically set for the hunt for the execution policy. So anytime you see star set execution policy star, trigger an alert. And so that's it for today. This is honestly just a scratch of the surface of what PowerShell is capable of doing. There's tons of stuff that we have not discussed: reflection, delegates, Win32 APIs, ETW, AMC, all manner of things that we have not had the chance to get in. This is just really supposed to be a very, very small precursor or primer on what you can do with PowerShell. And if you wanted to play with it in the future, this would give you the building blocks to at least start on that journey. So if you had fun today, I encourage you to keep digging into PowerShell. Again, it is not a silver bullet, but it's the sort of thing where if you apply it properly, you may find yourself having success in these operations. So it's really been a pleasure for me to be here today. Thank you guys for having me. It's always nice for me to be able to give back and try to share some of the knowledge that I've picked up over the past few years doing this. So thank you. And if you guys come out to B-Sides or Task or whatever the case may be, and you see me, I hope you come up and say hi and say what's up. We try to be to build a network is an important thing. So come say hi, and I wish you guys all the best of luck in your studies. And as a parting piece of advice, I just say, make sure that you stay curious. Just because you're tinkering with something, it may not be useful in your day-to-day work, but it's always good to kind of play around with stuff and see what's going on under the hood. So that's it for me. Thank you all for coming, and hopefully you found some of it informative.
All right, thank you for that talk. I can upload these slides for the PowerPoint in our CTF server if you want to take a look at that afterwards and try following along on your end. Up next on the agenda is at 12 our Q&A panel / resume roast. So definitely don't miss that out. We got a star-studded lineup for you guys. Until then, keep on solving those challenges.